Hello, this is Mr. Humbard here. For this video, I'm going to go over the Chapter 7, Section 2 notes. And hopefully this will help a couple people. So, let's move my face over here. The thing to note about this section is that momentum is related to force. We get this equation. It's not quite this, though. We'll divide momentum by time. That's not quite correct because we get this from this expression, F equals ma, and then we convert a to what its definition is, the change in velocity over some time interval, and then we multiply the time interval to both sides. So F equals m change in v over some time interval. Multiply the time interval to both sides. And we get some new quantity. We call this impulse. But also, when we do this, we get another quantity here, m times the change in velocity. That is the change in momentum. So impulse is change in momentum, and force. When we solve for force from these two, can equal change in momentum over change in time. So, not this one, this one. And here is our new equation. I equals F times change in t, or change in p equals F times change in t, or breaking up what this is, m times change in v equals change in p. There's a lot of different ways to write this, but you get the idea. Right. So 99% of the time, we aren't going to use the change in m equation. That will never pop up in this class. And that's for a reason. I'm not trying to make this complicated. We're always going to use this equation. Change in momentum equals mass times change in v. Right? So here's a quick proof of going through this. And this is how you solve one of the problems. M v final minus v initial. And it's always final minus initial. And in one of the problems, I think number 2, you're going to have to solve for the v final when you're given everything else. Oops. Alright, for a quick review, the triangle looks like that. Momentum equals mass times velocity from the first section. And also, if we're using the change in p, or the impulse, remember these are the same thing, change in p equals impulse, we can say that F and change in t work the same way. So when we do that, these are divided, and these are multiplied right here, between. Alright. So this theorem, this equation, it is actually called a theorem. This is the impulse momentum theorem. Remember that change in p, or change in momentum, is also the impulse. And the impulse is the force applied in the period of time. By definition, force applied, period of time. And the more time force has in contact with an object, that will increase the change in momentum. Because if we increase the F, or we keep the F the same, increase the T, of force is related to this, so the momentum will go up. If we increase the time, and what it's saying here, it can reduce the force depending on the perspective of the question. For instance, if you have F equals change in momentum over t, and you have a larger time, well, that would mean that your force would decrease if your momentum stayed the same. So bigger momentum, smaller force. All right. Here's a couple of quick examples. I equals F times change in some time interval, because impulse is force over some time interval, or that is, as we remember, the change in momentum. So for this, we don't actually care about the shopping cart, 20 kilogram shopping cart, the mass of it anyway. We care, this is M, about the force and the time interval. So 7.5 times 5. So 37.5. And our units, of course, is momentum units, because we're doing a change in momentum. So that's our answer. Because that's 5 times 0.5 is 2.5 times 5 times 7 is 35. 35 plus 2.5 is 37.5. So next one is if we have if it says an impulse of this is delivered with an object of initial momentum of that. So we're given I, or change in momentum. We're given P initial. We're not given P final. We have that one, and we're not this one. This one's not a thing. But it says impulse is in the same direction as the initial momentum, so that means our vector is in the same direction. So we'll say they're both positive, for instance, because that makes that simple. And now we can just put our values in. So 12.2 is our first value. That equals P final minus 4.5 is our second value. Add 4.5 both sides. P final equals 16.7. And this is a momentum, so kilograms, meters over second. And that's it for this section.